Howdy guys, welcome to another stats video. We're going to talk about two proportion Z confidence intervals today. So if we were interested in knowing are there more orange Skittles or M&Ms, we can construct and interpret a 95% confidence interval for the difference in proportions of orange Skittles and M&Ms. So what is the sample statistic for? I don't know why 4. I think it's just a typo. Let's get this bad boy where it'll let me write. Okay, so let's say that we had a bag of Skittles, well, a big bag of Skittles, like the party size, and the same for M&Ms. And maybe the proportion of oranges is 12 out of 69, which is 0.17. And the proportion of orange M&Ms is 17 out of 66, which is 0.26. So the difference in the proportion of orange Skittles and M&Ms, and order does matter here, right, is 0.17 minus 0.26, which is negative 0.09. Just like our other confidence intervals, we've got conditions that we've got to check. Is it random? We're going to say yes. Random samples were given. And remember what that does? That allows us to generalize results. %, yes, samples or less than 10% of all the candy. This allows us to assume independence. When sampling, kind of a mouthful, without replacement. So as long as our sample is not too big, as long as it's less than 10% of all the candy, then when we pull a sample without replacing, we still have independence. And then large counts, we'll check this. We're going to do 0.17 times 69 is 12. And 1 minus 0.17 times 69 is 57. Kind of gross 57. We'll make that better. We've also got 0.26 times 66, which is 17. Then we got 1 minus 0.26 times 66, which is 49. And all of these things are greater than or equal to 10. So what does this do? This allows us to use the normal distribution. Okay, so when I say they're all greater than or equal to 10, this guy's greater than or equal to 10, this guy's greater than or equal to 10, this guy's greater than or equal to 10, and this guy's greater than or equal to 10. And that's a must. Otherwise, we can't use the normal distribution. Okay. Construct and interpret a 95% confidence interval for the difference in proportions of orange Skittles and M&Ms. So the general formula is the statistic plus or minus the margin of error. Okay, which is going to be p hat 1 minus p hat 2 plus or minus z star times the square root of p hat 1 times 1 minus p hat 1 over N1 plus P hat 2 times 1 minus P hat 2 over N sub 2. Okay, so this is exactly the same thing just with 2's here. It's just kind of cut us off on the page there. What is this? This is the margin of error. And this is our statistic. So it's like what we've been doing, it's just there's two different proportions. There's two different sample sizes. Okay, calculator step. Well, we're going to use the bookmark site. I'm going to walk you through that. And N1 is 69. P1 is 0.1739. It's 12 divided by 69. N2 is 66. And P2 is 0.2576 because it's 17 divided by 66. This is going to give us a confidence interval of negative 0.222, comma 0.0596. I think that's a 9. We'll double check though. All right, I'm going to pause. I'm going to open up the bookmark site under today's blend and walk you through how we get this confidence interval. Okay, so I'm going to click on this bookmark site. I'm going to scroll down, 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 down. Okay, here's where I'm going to start entering that stuff in. N1 is 69. N2 is 0.1739. N2 is 66. P2 is 0.2576. Confidence level, is 95 because we weren't given a specific one, so I'm going to hit calculate. And I think that's it right there. This is our guy. Check to make sure it's exactly right. And it is a 4, not a 9, so I'll fix that. Okay, notice I fixed that to a 4, not a 9. I couldn't read my own writing. And so we conclude we are 95% confident that the true difference, we got to be careful about order too, in proportions of orange, Skittles first, and M&Ms is between negative 0.222 and 0.0546. So that begs the question, right? Or we can answer questions without running tests of significance sometimes by using confidence intervals, right? And so we can answer this question. Does the interval provide convincing evidence that there is a lower proportion of orange Skittles than orange M&Ms? Well, if there was a lower proportion of orange Skittles than orange M&Ms, this entire confidence interval would be negative, right? Because we're taking Skittles and subtracting Skittles proportion, we're subtracting M&M's proportion. So if Skittles is smaller, this whole thing would be negative, but zero's in here. So we're going to say no, because the interval includes 0. So it's possible that they're equal. We don't have evidence that Skittles is orange. There are fewer orange Skittles than orange M&Ms. Okay, so big ideas for confidence intervals for P1 minus P2. So we're going to use our bookmark site where X1 is number I don't think we want this. It's more like fruit. We will say if both endpoints of the interval are negative, then we have evidence that P2 is greater than P1 if both endpoints are positive. We have evidence that P1 is greater than P2, and if the interval includes 0, like our example we just worked, we don't have evidence. What's the word have? Kind of gross. Sorry. We don't have evidence that P1 and P2 are different. They might be, but we don't have evidence of it. Okay. So the rest of this is a check for understanding. It's a homework assignment that you guys have on Blend, and you got the key on Blend as well. So if you have any trouble over this stuff, come and see me during office hours and I can help square it away. All right. Adios.